Bio 1 students, Mr. Yance again. We're going to finish up upside down, Mr. Yance. We're going to finish up notes today on genetics. So when we finished up with this slide, a pedigree, I showed you the royal family, how they transfer hemophilia to the boys in 3 of the 4 royal families. It basically, as I said earlier in past notes, it's just a visual aid, a chart that shows you how things are passed through different generations. So you can do this just for family tree, or you can do it to trace genetic diseases, is what we're talking about in this chapter. So what we have with pedigrees is a circle is a symbol for a female. A square is a symbol for any male, okay? If they have open circles or open squares, it means they don't have any diseases or genes for that disease, okay? Lines and symbols mean things on pedigrees as well. If we connect a circle and a square, that means they are a couple, okay? And then lines coming off of that couple means that is their children. And it goes from left to right. So firstborn is on the left side, and then you work your way to the right, and you get younger, okay? So here's a case where these were fraternal twins, the boy and then the girl. It's a diagonal line. If they're a diagonal line and they're connected, and obviously 2 circles or 2 squares, that would be an indicator of 2 identical girl babies or 2 identical boy babies, okay? And there's what I just said, married and siblings. So this would be a girl would be the firstborn, a boy, a son would be the secondborn, and the third one would be another girl. So you can actually do your own family trees like this as well. Now, what does it look like? So let's take a look at this. So let's say, for argument's sake, this would be your grandparents, okay? This would be, obviously, they had each of these grandparents had 3 children, a boy and 2 girls in this case, 2 boys and a girl here. And their youngest girl marries the firstborn or oldest boy from this couple over here. So now these get married. So this would be the first generation. Then they have 2 kids. So this would be second generation, parents, grandparents. That's how that works, okay? So you can do this big flow chart like I showed you with the royal family, okay? Now, when we start talking or tracing genetic diseases, these symbols have meanings. If the whole thing is filled in, that means they have the disease, okay? If they're a sex-linked carrier, X carrier, sex-linked, X-linked, that we talked about last notes, we put a dot in there, okay? That means they're a carrier. Don't have the disease, but they're a carrier. An autosomal carrier would be a half-shaded, I don't know why this isn't shaded, a half-shaded circle or square, okay? So that's what those shading in does make a difference, okay? So when you interpret a pedigree, you can detect a lot of things from looking at a pedigree. We can figure out if it's on the autosomal, 22 of the chromosomes. If it's a sex-linked one, we can tell that by looking at how many boys or girls have a disease, okay? In most of the males in pedigrees that are affected, then that would be a sex-linked one. If it's a 50-50, boys and girls equally get it, it's probably an autosomal type of defect. So you can see, let's look at this one. Is this an autosomal or sex-linked? Well, it looks like the boys and the girls have an equal chance, and that means it would be an autosomal because half the women and half the boys have it. There's no distinction between the 2 of them, right? And you also can tell if it's dominant or recessive. If it's dominant, then one of the parents must have the disorder. If the disorder is recessive, then maybe neither one of the parents have it, okay? So you can see I got a couple examples here. This would be a dominant one because both parents have it, and they're going to pass it on to the majority of their kids, okay? You can see that down here in a bigger pedigree. Recessive means here's one parent has it, but you may skip generations, and then it shows up again, okay? So I think I put those examples in your chart. It's just a good way of tracing diseases down, okay? I don't know if I put this in your notes or not. I think I did. You can see if it's a dominant recessive. This one would be recessive, obviously, because neither one of the sets of parents have it, but then it shows up down here, okay? So in summary, pedigrees are nice family trees that explain genetic history. They also can show you birth orders and descendants, so you can use them for lots of purposes. In genetics, we're obviously trying to figure out, are these diseases autosomal? Are they sex-linked? Are they dominant? Are they recessive? Okay. Hopefully that makes sense. And if you go back to that royal family that we talked about, you can see all this right here. If you go back to this slide, you can see how this became sex-linked. And we probably should go back and fix this and make dots in here for the girls instead of half shaded. We can show it a couple ways. It just means they're carriers, but for a sex link one, those probably should be dots in those circles, and then solid squares for the boys. All right. Hey, hopefully that makes sense. That's it for notes. We'll have a quiz over Punnett squares. We'll take a test over this, and we'll be done with genetics. All right. Hey, have a good day. As always, you got questions, shoot me an email. We'll see you later. Bye.